Welcome back to COSC 1437. We are going to be starting chapter 4. Go and share my screen. So with chapter 4, we're going to start talking about control structures. And the specific control structure that we're going to cover is the selection control structure. So there are 3 methods of processing a program. The first method is in sequence, which is what we've been doing. So we just take the first statement, then we process to the next statement, and we go to the third statement, and so on and so forth. So top down. The second type of processing method is branching. And branching is what we're going to cover in this chapter. And branching just means that we're going to be taking, so we start at the top and we may take a different, we can have different options in our program depending on a condition. So like if I say yes to a question, then I'm going to go do something different in the program versus if I said no. Lighting is so bad. And then the third method of processing a program is using loops. And this is just for repeating processes. For example, if you want to keep somebody at a certain screen until they enter the correct password, or maybe if it's a video game, you're going to stay a certain screen until you have so many points, and then you can go to the next screen. So we have loops for those types of needs. Programs, large programs will have all 3. Of course, we always have sequence, but all programs will have branching and looping. This here is an example of flowcharts for the 3 methods of processing a program. So these 3 methods are shown here of how we would write them using a flowchart. So when you have a flowchart, you always have a very small circle that says, okay, here's where I'm starting the flowchart, or where I'm ending my flowchart, or where I'm starting my program, where I'm ending my program. And so anytime you have a statement, your statement is going to be in a rectangle. So this is sequence, statement 1, statement 2, all the way to the last statement in the program. A selection would be, here is we would have that question, or we would have that comparison would be right here, and it's always a diamond. So a diamond always has some kind of comparison logical expression, something that comes out to true or false, like did they enter a Y? Did they enter an N for no? Did they enter the correct password, yes or no? So if it's true, then it's going to take this path and do whatever statements you have here. Could be 1 or more statements. If it's false, it would do these statements. So basically, if it's false, these statements would never happen. So this is selection or branching. You can have a true-false branch from here, and you can have in either one of these, whether you go true or false, you could have other branches inside those, or you could have repetition inside here. So repetition, the way that if you were going to show this in a flow chart, you would have your question here. So you log your expression that gives you a true or false. If it's true, you do whatever it is that you want to do, and then you repeat the process and you ask, is it true? Then do this. This will, a repetition will keep repeating while true. The minute that it becomes false, that's when it stops. So with repetitions, we need to have them, we need to have at some point, they need to become false. Because if they don't, then you'll have a loop that goes on forever, or a I'm trying to remember the word of how you call it, a loop that goes on forever, but you'll have a loop that goes on forever. Okay, so your logical expression has to come out to false at some point. Relational operators, they allow you to make comparisons in a program. So relational operators are things like equal to, not equal to, less than or equal to, greater than or equal to. These are binary operators. Remember, binary means that you need something here on the left, you need something here on the right. So you need two things. Could be two variables on each side. It could be a variable compared to a number. Like, let's say you have a variable called grade. You could say, is grade less than 90? That could, be the comparison. Remember, by means two. So relational operators allow you to make a comparison. They're binary operators. The condition is represented by a logical expression in Java. A logical expression is an expression that has a value of either true or false. So these right here, you'll compare two things and it'll either be true or false. Notice that if you're comparing to see if something's equal, you cannot use one equal sign. One equal sign is to assign. It's an assignment statement. So do not use just one equal sign to compare. You got to have two equal signs. They're next to each other when you type them. There's no space in between them. Not equal to is an exclamation point and then no space and then an equal sign. Less than, or equal to, greater than, or equal to. So make sure that you know these relational operators, that you know how to write them and know what they mean if you don't have the description. Relational operators and primitive data types. So remember, the primitive data types are things like ints, floats, doubles, chars. Those are the primitive data types. So not string. String is a class. So relational operators and primitive data types can be used with integral and floating point data types, can be used with the char data type, Unicode collating sequence. Okay, so what is the Unicode collating sequence? So if you remember back, I think it was chapter 2, we talked about how each letter has a number that is mapped to it, so that you compare two letters and you can know which letter is bigger, or not bigger, but it comes first. So if you're putting something in order from A to Z, you can say, okay, is this last name less than this last name? And maybe this last name is Anderson and this one is Thomas. Well, Anderson is less than Thomas. Anderson comes before Thomas because A is less than the T, if they're capital. And in your book and on here, you'll see part of the chart. So here's capital A is 65. So if I compare capital A to T, T is going to be larger. So T is 84. And so this is how, when we compare characters and we compare strings, it's using these to know what comes first. And you can see if it's less than or greater than. This is not the entire chart. This is just part of the chart. Okay. So here are some examples of how we can compare characters. So here, this first one here is just a blank space, and this is the lowercase a. So a blank space has a value of 32, and a lowercase a has a value of 97. So blank is less than lowercase a. And then this one here, you don't need to look at the chart. You just know that R, OPQ, R comes before T. So this would give you a false because R comes before T. R is not greater than T. So these are a little bit harder because you would have to look at the Unicode to see what the plus sign, but what the value is for the plus sign, what value is for the asterisk. So the plus sign has a value of, see, asterisk is 42, plus is 43. So it says it's the plus less than the asterisk. That would be false because remember the asterisk was a 42 and the plus sign was a 43. Typically, we're not doing this kind of comparison. What we're comparing is characters that we know, A through Z, and that's the only thing that we're comparing. This here are Boolean operators. So the logical Boolean operators also will come out to a true or false, except with this very first one here, the not operator, this is a unary operator. So you just put it like in front of a variable. For example, if you said, do you like cats? And you ask them to either enter a yes or a no. And let's say that I entered, yes, I like cats. And then you want to say, okay, if not true would be false, then do this. So not in front of something that's true would change it to a false, and not in front of something that's false would change it to a true. This is and or. For example, if you say, if you are 16 years old and you have a driver's license, then this happens. Or if you say, if your grade is greater than or equal to 90 and less than or equal to 100, then you have an A. If your grade is less than or equal to 70, no, I'm sorry, greater than or equal to 70 and less than or equal to 79, then you have a grade of C. So this is and. You have to use two and percents next to each other, no space, not the word and, not the word not. This is for or. So and both sides have to be true to be a true statement. With an or, only one of the conditions. So there's going to be a condition here and a condition here. Only one has to be true for this statement to be true. So you can say, okay, if you are 16 or you drive, okay, so only one has to be true. If you're 16, it's a true statement. If you drive, it's a true statement. So we talked about the not operator. So all it does is it just reverses. Not true is false, not false is true. Here's an example. Is A greater than B? Well, A is not greater than B. So this here gives you false. Not false gives you true. Is 6 less than or equal to 7? Yes, true. 6 is less than 7. Not true would be false. This is the and. So with an and, everything is false if one of the expressions on either side is false. So here's an expression or a condition, right? This is a condition. This is a condition. This gives you true or false. This gives you true or false. And then if one of these is false, the whole thing is false. Now, here's the other thing. If this condition, this expression here is false, the compiler doesn't even waste any time looking at this. It doesn't care what you have over there. Because if this first one is false, it doesn't need to know anything else. It knows that this is going to be a false condition. Okay. So let's look at this first one. Is 14 greater than or equal to 5? Yes, so that's true. So since this is true, we have to look at this side and see if it's true. Is A less than B? That's true. So because both sides are true, then this is a true statement. That's the only time with an and that you can have a true statement. The second one, is 24 greater than or equal to 35? It's not greater than or equal to 35. This is false. We don't need to look at this. It's just we know it's going to be a false statement. Then with the or operator, we do have, with the or, only one side has to be true. So if the first side is true, then you don't have to look at the second side, the second condition or expression. So if this is true, it's going to be true. This is true, it's going to be true. This is false. Now we have to look at this side. It's true, so that's going to be true. This first one is false, so we have to look at the second one. Second one is false, so it's a false statement. That's with the or. Okay, so these operators do have a precedence, like it has an order of operation, just like we have an order of operation for the plus and the minus, multiplication and division. So these also have an order of operation. The unary operators, the not, the plus, like if you have like +5 or -5, right? Just a negative in front of a 5 to make it a negative number. Those are going to have the highest priority. Then it's going to process multiplication, division, and percent. Then it's going to process the plus and the minus. Then after it does all of these, then it looks at the logical operators, the less than or equal to, greater than or equal to, or greater than. All these have the same precedence. Then next is the equal to or not equal to, then the and, then the or, then the assignment operator has the lowest precedence. So you have to learn this table here so that you're able, on a quiz or a test, you're able to look at an expression and be able to tell me if it's true or false. So it would look something like this on a quiz or a test. You would have something like this, maybe not this large, this is pretty large. And then you would have to say, does this come out to true or does this come out to false? So let's take a look at this one and let's just process it slowly, okay? So something that wasn't on the table is parentheses. Anything in parentheses, we just do all together, right? So we're going to do everything here in parentheses. We're going to do everything here in parentheses, everything here in parentheses. After we do these in parentheses, oops, let's go back. Then we're going to do this not. We definitely have to do the not and change whatever this comes out to. Then we have the or and the and. So which one do we do first? So if we go back to the table, we have to do and first. So we would look at if this is true or false and look at whatever this gives us and then figure out if this is going to be true and false. Then only then can we do the or statement. Okay, so let me get my pen here. All right. So let's do this here first. So again, we can't do 17 less than 4 yet. We have to do the multiplication and addition first. Multiplication comes before addition. So we're going to do 4 times 3. 4 times 3 is 12. 12 plus 5 is 17. So this here is 17. Is 17 less than 17? Well, that is false because 17 is equal to 17. If this said is 17 less than or equal to, it would have been true. But it's not. So I'm going to put an F here because that's false. Okay. Then I'm going to look at this here. And this says 8 times 2 is 16. 4 times 4 is 16. Is 16 equal to 16? Yes, that is true. Then with this and, now remember we're going to do the and first. Because this is true, we have to look at this other side to see if it's true or false. If this would have been false, we don't even have to, we don't even care what was over here. But since it's true, we need to look here. So this is 3 plus 3, 6. Is 6 equal to 6? Well, this is true, right? 6 is equal to 6. But then we have not true. So not true gives us a false. So now we're going to do the and. We have a true and a false. Remember with the and, it has to be both. You have to be both because you're an and. Like, are you a girl and are you 6 feet tall? You got to be both a girl and 6 feet tall, not just one. So this here is false. So this gives me a false statement. True and false is false. And then we're going to have a false or false. False or false is just false because they're both false. Doesn't matter, but an or and and. So our final answer for this would be false. And that's what you're going to be expected to be able to do something like this and be able to process this on your own. Okay, let me clear all the drawings. All right, so this is an example of a small program. So we have Boolean found equals true. So Boolean is a data type that either gives you true or false. We have gone ahead and set it to true. Okay, so initialized it. We initialized it to true. Remember, this is reserved word, and this one's also reserved. Double hours equals 45.30. We defined the variable called hours. We assigned it these many hours. We defined a variable called overtime. We assigned it these many hours of overtime. And then we have count equals 20. And we have a character called B that we defined. So consider the following expressions: not found. So not found would be not true, which gives you a false. Is hours greater than 40? Yes, hours is greater than 40. It's 45. Not found. So again, not found is true, false. Sorry, because it was true. Oops. Get my pen. Okay, so this is not working. Okay, so this is false. There we go. Found is true, not true is false. Is hours greater than or equal to 0? Yes, right? Hours is 45.3. So this would be true. Oh, by the way, so here's an example because this is false and this is an and, we don't even have to look at this, right? We know it's going to be false. It's just going to be a false statement. So we don't really care what's over here. You don't have to waste your time looking over there. You know it's going to be false. Okay, and then there's some more examples here that you can go through on your own. All right, this is really important because I see students do this in their program. So let's take a look at this. We cannot put a variable in the middle like this and then do comparisons like that. You have to have, these are binary operators. So you have to have a variable, you got to have 0 here and a variable here. Then you have to have a variable again and compare to 10. So here, if you maybe want to say and, you could say is 0 less than or equal to num, and is num less than or equal to 10. You can do this, but you cannot do this, and you cannot do this here. So I don't see this very often, but I do see a lot of students doing this right here. Okay, for selection, we have one-way selection, we have two-way selections. We have a compound block of statements. So meaning like, if it's true, you do multiple things. Multiple selections, which is an nested, like if your grade is between 90 and 100, you made an A. If your grade is between 79 and 89 and 80, you made a B. Else, if your grade is between 70 and 79, you made a C. So that's multiple selections. And then we're going to look at conditional operators and switch structure. So that's the next part of our section here on the slides. So the one-way selection is just very simple. If the expression is true, you then do something, but there's nothing specific that you want to do if it's false. You're just going to continue on. If it's false, you just continue with the program. The expression is your decision, and the statement is your action. So this is your decision. This is your action. What will you do if this is true? Notice that if is in blue, so that's reserved, it's lowercase. You have parentheses for the expression. So this is where you put like if x is less than 10, then do this. So this is how we flowchart a one-way selection. Here's our expression or our condition. If it's true, do this. If it's false, you just keep going with the program. Here's an example of a one-way selection. So it says int number, int temperature, string, num string. We're asking the user to enter an integer. They're entering the integer into a pane, to a little window. So we have to remember, when you enter it into a window, it captures as a text. So then you have to parse it into an integer. And then that number that they entered, it's going to be a temp, meaning not temperature, but like a temporary number, temporary location. So number and temp have the same value, whatever you enter. So if I enter a 10 here, I just take that 10 and assign it to this temp variable. Then it says, if the number that I entered is less than 0, so if I entered a negative number, then number equals negative number. And then it shows the message, the absolute value of temp is number. So basically, if I enter like a -5, then it would say the absolute value of -5 is 5. So this here is your selection. If open parentheses condition it has to evaluate to a true or false, close parentheses, and this is what happens. It's only going to do one thing if it's true. Here's an example of how it would run. The absolute value of -6734 is +6734. Now, a two-way selection looks like this. If expression, if true, do this, else do this. So if it's true, it does statement 1. If it's false, it does statement 2. So the else statement always has to be paired with an if statement. If you have an else without an if, you're going to get an error. Here's how we a flow chart, a two-way selection. Here's an example. If the hours is greater than 40.0, so greater than 40.0 would be if you worked 40.5 hours or 41 hours or 42 hours, then wages equals 40 times rate plus 1.5 times rate times hours minus 40. So here this little equation here calculates overtime pay. Overtime pay for this company is if you work more than 40 hours, you get time and a half. So if you get paid $20 an hour and you work overtime, you get $30 an hour. So first of all, it figures out how many hours did you work overtime. So let's say you worked 45 hours. This here would give you 5. Then you multiply 5 times that time and a half. Now, if it's false, if you worked less than 40 hours, or if you worked exactly 40 hours, then it goes to this statement here. So this is just greater than 40. So 40 or less goes to here, and you just get regular pay, hours times the rate. Okay, so going back, notice that when you have parentheses here, there is no semicolon here. The semicolon is at the end of the statements only. So no semicolon here, no semicolon here. So the next slides, what it talks about is what happens if you do put a semicolon here by mistake. Because a semicolon follows the closing parentheses of the if statement of line 1, the else statement stands alone. The semicolon at the end of the if statement in line 1 ends the if statement. So this is going to happen. It's going to find out if hours is greater than 40, but if it is greater than 40, this is never going to happen. It's never going to calculate wages ever because you have a semicolon. Since there is no separate else statement in Java, this code generates a syntax error. And then I missed something here. Some of the statements. That is else is by itself. Yeah. Okay. So basically it's saying this else gets it's all by itself because this if ends. And so because the else is left by itself, then that's what gives you the error. There's no if to attach to the else to pair when you have the semicolon here. Okay, so let's take a look at this. So this is a two-way selection. But you might, so notice that these two lines are aligned. even though they're aligned, the only thing that's going to happen if it's true is that grade will be set to A. So if score is greater than or equal to 90, grade gets set to A. But if score is less than 90, then it's just going to print out grade, and it's going to print out, if you initialized it to something, it'll print that out. It'll just print out gibberish. So if you want there to be two lines attached to one condition, you have to put open and close curly braces. You have to use these right here. So this is how your statement would look. If age is greater than 18, then do these two things. Else, do these two things. So if you have more than one statement that goes with your expression, we call this a code block or a condition code block, then you got to use the curly braces. This is our multiple selection or our nested if statement. If true, do this. Else, if true, do this. Else, do this statement. Else is associated with the most recent incomplete if. Multiple if statements can be used in place of if-else statements. It just may take longer to evaluate. It may take longer to go through it, to get through all three of them. So if this is true, it's going to do this statement. And if it does this statement, number one, then it just exits. Okay, the minute that it does one of them, it exits. So if this is true, if this is false, then it's going to check this one, and it's going to check to see if this is true. If this is false, then it goes to this one. But if this one is true, then it just stops and it keeps going over here. It doesn't ever do that. It doesn't even, well, there's nothing to check, but it doesn't go into here. So this if goes with this else, this if goes with this else. Here is an example. If the balance is greater than or equal to this amount, here's interest rate. Else, if the balance is greater than this amount, we set interest rate to 0.04. Else, if the balance is greater than or equal to 1,000, set the interest rate to that. Else, any other balance gets 0% interest rate. If else, if else, if else. Now, this might be easier, the way that they have it here written might be easier for you to match your if else, but the convention of writing if else's in Java is like this. They put the if right next to the else. Also in C++, you'll see this. So here it is, the ifs next to it. Now, in this example, we have an if-else embedded in an if statement. So if the temperature is greater than or equal to 50, then it's going to check for this. So if, let's say that the temperature is 90. So is 90 greater than or equal to 50? Yes. So it goes here and it says, is 90 greater than or equal to 80? Yes. So then it says, good day for swimming. If the temperature is 70, 70 is greater than or equal to 50, but 70 is not greater than or equal to 80, so it would go to the else statement and it would print out good day for golfing. Let's say that the temperature is 49. Is 49 greater than or equal to 50? No. So it goes all the way to the else over here and it prints out good day to play tennis. So this is the same thing as we just saw, except they left out this here. Like what happens if the temperature is not greater than or equal to 60? Okay, so here's another example of an if-else statement. We have if the month equals 1, print January. else if month equals 2, print February, else if month equals 3, so on and so forth and so forth. So in Java and C++ and C, we have other ways that we can do this. Now, before I look at that, remember, if month is 1, we'll stop here. We're not going to compare. We're not going to do these comparisons, right? Because it's else if. But for this one, if month is 1, it prints January and it still goes and it checks to see if month is 2 because there is no else. And it checks to see if month is 3 and 4 and 5. So this really just wastes time. So make sure you put the else in there. So we have something, okay, I guess before we go into that, the short circuit evaluation was what I was talking about earlier, is that if you have an or, and this is true, it stops and it doesn't look at the next, it doesn't look at this. If this is false, it stops, it knows it's false and it doesn't look at this. So that's short circuit evaluation. This is comparing floating point numbers. So let's see, what is it doing? Don't see a comparison. Okay, let's look at the next one. Okay. X and Y are the same within the tolerance of 0.00001. So what it's saying is that there's a tolerance of when you're looking at floating point numbers, that it's not looking to see that it's exactly the same in the floating point numbers. So there's a tolerance number. And I have to play more with this to see exactly how this works. We can put something on there. Okay, so here's the sample run. So this comes out to 0.999. This comes out to 1. And then it says X and Y are not the same. Okay, so let's see here. So if we have the absolute value of X minus Y, is it less than 0.0? Okay, so is X equal to Y? All right, so here it says X is 1.0 and Y is 0.99. So X and Y are not the same. Oops. Okay, so that's what we're comparing right here. But then here, X and Y are the same within the tolerance range. So here we did something a little bit different. We took the absolute value of X minus Y and compared it to 0.001, 0.00001. And it said they are the same. So what is X minus Y? So if X is 1, X minus Y is point. Oh, I see. Okay. All right. So not really sure what they're trying to show on here. Okay, comparing floating point numbers of equality. The preceding program and its output show that you should be careful when comparing floating point numbers. One way to check whether two floating point numbers are equal is to check whether the absolute value of their difference is less than a certain tolerance. Okay, then X and Y are equal if the absolute value of X minus Y is less than 0.000001. To find the absolute value, you can use the function math.abs of the class math. So you have to import the math class. Therefore, the expression math.abs x minus y less than 0.00001 determines whether the absolute value of x minus y is less than that. Okay. So it's saying don't just compare floating point values. Do this here where you say absolute value of x minus y less than, and then compare it that way to see they're equal. Okay, conditional operator, the question mark. Okay, so this is another way to do an if statement is by using the question mark. So the if expression 1 equals true, so if this is true, then the result of the condition is expression 2. Otherwise, the result of the condition is expression 3. So we're saying, so for example, sure there's an example here. Maybe not. Okay, I don't have an example that I see. All right, so basically what they're saying is if you do, you can type this in. So you could say something like this. Let me get the pen. Just a second. Okay, so if I say, is the grade, so let's call it G, is the grade equal to 100? Okay, so if it's equal to 100, if it's true, then it's going to do expression 2. It's going to do whatever you have here. But if it's false, it's going to do this. So true here, false here. Okay, avoiding bugs by avoiding partially understood concepts and techniques. So let's take a look at some of the bugs that we can avoid. So looking at this program, you have GPA. We ask the user to enter the GPA. So let's say that your GPA is 3.5. Is 3.5 greater than or equal to 2.0? Well, yes, 3.5 is greater than. If the GPA is greater than or equal to 3.9, you're in the honors list. Otherwise, your GPA is below the graduation requirement. So here's an example run. They entered 3.91 as the GPA, and it said they're in the honors list. They entered 3.8 for the GPA, and it said is below the graduation requirement. See your academic advisor. Well, 3.8 is not a bad GPA, so let's find out what happened. So let's go back. And so if we say if the GPA is greater than 2.0, which it was, right? It was greater than 2.0, it was 3.8, but it's not greater than 3.9, so it doesn't print this. This else right here belongs to this if. This else does not belong to this if statement here, even though they're aligned. So that's why it gave them this problem here. So to fix that, what we can do is we can use an open brace here and a closed brace here. And then all this, you can clearly see, oh no, actually we don't want this to print if it's below. So what we need is an open brace here and here. So let's look at how they fixed it. Yeah. So open curly brace, close curly brace. So if the GPA is something less than 2.0, then it just tells you you're below graduation requirement. But anything greater than, it's just going to go here. And it's not going to do anything else other than tell you. So 3.8 doesn't do anything. If you enter 3.8, you don't actually get a message. So you enter 3.8, you don't get a message. So maybe we enter a message or something. Okay, so the last thing we're gonna look at is something called the switch structure. And the switch structure would be something good to use. Let me plug in my computer because I'm running out of battery. Would be something good to use for a program like this, which I thought that's where we were going. Okay, so like if you have month and it equals 1 or month 2 or 3 like this, something like that, the switch statement would be a really good statement to use. So let me just give you an example of a switch statement. So many. Okay, so here's the switch. This is the variable that we're comparing. And what it does is it compares to see if this variable grade is equal to this letter. If it's equal to grade A, to capital A, then it prints this out and then it breaks. Breaks means that it gets out of the switch statement. Switch statement is done. If it's not equal to A, then it goes to here. If it's not B, it goes to here. If it's not D, it goes to here. Let's say that you entered the letter E, and E is not one of the options, then it goes to this default statement, and it says the grade is invalid. So you enter something invalid. So this is the switch statement. I love the switch statement. So I want to stop there, and I want to show you with the switch statement some of the things that you can do. Okay. So let's do the one that had I'm trying to think of a good switch statement. So let's switch on. So first of all, let me just show you how it's structured. So you have switch, open and close parentheses. This is where your variable is going to be. And then these are going to be your cases. So you have case, something, and then a semicolon, and then how many ever cases, and then you have default. That's going to catch, the default catches if somebody entered something incorrectly, or or catch all, like anything else you entered, it's not good, you didn't pass or whatever. Okay, so here's a good one. So let's say that I'm going to enter a grade, like a 90 or 95, something like that. So I'm gonna say it's gonna be an integer. I'm not gonna allow for any grade other than whole numbers. And I can ask for them to enter the grade, but I'm not gonna ask them. I'm just gonna assign a grade. I'm gonna assign the grade of 90 just for testing purposes. I'm gonna show you how this works. Okay, so if we put grade here, and I'm gonna work backwards. So no, not 90. So like we did earlier where we had a character, char, grade, let's say it's an A. Okay, so they have a grade of A. So what I want to do is if they have an A, a B, or if they have an A or a B, then I want to give them the same message, like great job, right? A's and B's are awesome. So I'm going to say if it's an A, then I'm not going to put anything. And now I'm going to say system dot out dot print line. Type for some reason. Great job. And then break. And we'll explain what's going on here. Let's do KC. KC is not terrible, right? So how about for C, we put not bad, hard or something. Okay, and then for default, anything else, whether, well, I guess for D and F, we could have a separate message, and then the default could be something else like, incorrect. The default could be invalid grade. Okay, and you could tell them enter an A, B, C, D, or F. Okay, I haven't done the D or the F, but here's what happens. If you don't have a break here, if there's no break, what it does is we call this, it falls through to the next statement. So if it's an A and there's nothing to do and there's no break, it just falls through to the B. And it does whatever is in B. So whether you type in an A is going to print this out, a B is going to print this out, a C will print this out, and everything else will print here. And we can do a D or an F also. But let's just run this one. Okay, so the grade was an A, so I printed great job. So it just went through and it did whatever B said. Now, you can also add a statement here. And you can say, wow. So since I don't have a break, it's going to say, wow. And then it's going to say, great job. It's going to print both of those statements because there is no break. So it just falls through. So it says, wow, great job. Okay, so this is our switch statement. I'm going to see if there's any other examples for the switch. That's all. The rest are just some, just talks about some examples in your book of some programming examples. And then it talks about comparing strings. So to compare strings, you can use the less than or greater than signs. You can use that to compare strings. Like I said earlier, you can compare like Thomas and Aiden and see which one comes first. Or you can use the methods compare to or equals. So these are methods that can be used with strings. So here's an example. If we say string 1 dot compare to string 2. So here string 1 is hello, string 2 is hi. So E comes before I. So it says string 1 equals hello, string 2 equals hi. The first character, they're both the same, but the second character is different. E comes before I, therefore, hello is less than hi. So the value would be less than 0. In this example, we're comparing string 1 to hen and trying to see which one is bigger or smaller. So here's some examples using compare to. So this is our control structure called if, else, and switch, which is our conditional statements. In the next chapter, we're going to be looking at the loops. You do not have a lab for this chapter. You're just going to take a quiz, and then you're going to use the conditional the if else and switch, you're going to use those with loops in the next lab. Okay. Make sure you practice with those logical operators, those Boolean operators, and you know what the order of operation, that's really important. And look at on the if and the else, like where do you put the parentheses, the semicolons, and the curly braces. That always gives people problems, those curly braces, matching them and making sure you have that all correct. Okay, guys, have a good evening.